Hey guys, we are here assembled today for milestone 4 phase 2 of batch B22. Uh, Project title is recommendation system for farming using machine learning and IoT. Recommendation system. What do you mean by that? We'll be recommending the crop and the fertilizer. How, why, what, when, where will be done in the further slides. We express our sincere gratitude to Miss Kavya Priyamal for her sheer guidance. And without further ado, let's get started.
As we all know, farmers are the backbone of our country. Farmers form the core part of our system. Crops grown by the farmers first goes to the local vendors. From local vendors, it goes to the high level production, and from there, it goes to the entire nation. So farmers give us the most basic and essential need to survive. So, having this much importance, they are facing a lot of issues. For a crop to grow in a good condition, there are a lot of factors affecting it. Farmers might not be actually able to keep an eye on everything. They still follow the traditional methods for deciding upon what crop to be planted on that soil and which fertilizer to use for that land. And even the climatic conditions is also not in sync with that. Nobody knows when it will downpour heavily. Nobody knows when there will be any pest attack, and if the same crop is grown repeatedly on the same soil, it takes away all the nutrients present in it, making it poor. And for some crops which require, and there are so many crops which require a very standard amount of water. Too high or too less will definitely damage the crop. So while some of the farmers are successful, but most of them face these issues. And this is what we want to address and help the farmers in the entire farming procedure. We want to aid them with informed decisions so that they can make the good choice and choose the best. And we believe that the rise of new technologies can help us through this.
Okay, so coming to the literature survey part, extensive survey was done and we had referred to more than 20 papers. Every paper had its own strengths and weaknesses, and our aim was to utilize the strengths of these papers while removing the drawbacks. The key takeaways from our literature survey is as follows. The first one is automatic irrigation system. We got the idea of the automatic irrigation system from one of the papers. The automatic irrigation system there did not consider the soil moisture level. Instead it considered the water level in the storage tank. We have considered another approach to overcome this drawback, and soil moisture sensors were used in our project, and we got the idea from these papers. And network coverage, few of the papers used low network coverage devices like Zigbee, technologies like Zigbee and Bluetooth. We have used a module called as LoRa, which has higher range. And coming to the recommendations were not applicable to real world cases. So we have like our model has more accuracy compared to the other models which are present in the other papers. And hardware, we have used different sensors. The idea for using different sensors was taken from this literature survey. And also algorithms, few algorithms like deep learning models and neural networks were used, which was not actually necessary for solving these problems. So we have used simple algorithms to solve the problems. Coming to the individual approaches, each of the modules which we have integrated were individual modules. They weren't available as a complete package. And heavy architectures were used, as I told before. Deep learning models and neural networks were used for solving problems which could have been done by using simple machine learning algorithms. So we have overcome the drawback by using simple algorithms. Low connectivity networks, Zigbee and Bluetooth were used. That the connectivity range of these technologies were very low. We have used LoRaWAN, which has a connectivity of up to 1 kilometer. In our project, it can be extended up to 10 kilometer with the use of a bigger antenna. And all these were not available as a centralized system. So these were the existing approaches.
So, keeping all the pain points into consideration, we have a lot of improvements in the proposed system. We will be giving the real time data of what's happening inside the soil through the sensor values so that they can have all the data on their fingertips. We are recommending crop and fertilizer which best suits for that soil and weather conditions of that location. And for this, we are using our own curated data set, and we are using LoRa module, which is a state-of-art technology for high area coverage. We can get data transmitted up to 10 kilometers by using this LoRa, but due to some budget restrictions, we are using a module which transmits data up to 1 kilometer. We are automating the irrigation system to release or block water to the land by considering the soil moisture level. We also have Google Assistant integration, which will be a much easier way to get the recommendations.
Okay, moving on to the comparisons of the existing and what we have proposed. There are a lot of features that are going to be used for predicting the crop, which are not done in the previous papers. So we are taking into consideration the NPK, pH values of the soil, the temperature, humidity, and as well as the rainfall. So these features make a pretty good explanation of how the crop must be planted, or what type of crop must be planted. And we have a whooping accuracy of 99% in the classification algorithm, which is done through naive base. And moving on, the datasets that we used for the training was curated after extensive research, and it was self-curated, excuse me, and integration of many sensors. What I exactly mean by this is, after doing the extensive literature survey, we took bits and parts of the hardware that were used, and we added our own ideas and brainstorming sessions to actually analyze what would be the best use case scenario, or what would be the best sensors to be used for giving the real-time data of the soil. And we integrated a lot of these modules to serve a single great package to the farmer, where he'll be getting the real-time data, the recommendations, and easy access through data via his fingertips or just Google Assistant and all that. And renewable sources of energy like solar panels were also taken into consideration, so that there is no need of extra money that the farmer has to pay.
Yes, our system and we are recommending in our project, we are recommending crop and fertilizer recommendation to the farmer. So we are giving the real-time soil data to the farmers in his fingertips, and we are integrated automatic irrigation system and the Google Assistant, so that the farmer need not to be login, or he need not to be go to the website to check every time. So he can use his Google Assistant to ask what is the soil moisture level, or what is the crop that he is want to be planted.
Okay, in addition to that, we might have come across the term as centralized system. The initial plan was to build a grid system of sensors which send the data to a receiver module at a farm, and collectively all farms together send the data to a centralized database system. But due to the budget constraint, we planned of implementing the MVP or the POC, and hence what we have implemented in our project, that which you will get to see, is the sender and the receiver for one farm, the recommendations for and the recommendations and real-time values of a crop for a particular soil for one farmer, and the Google Assistant integrations as that's mentioned in this slide. So we have built a minimum viable product. While this can be expanded to the further grid system or anything, due to budget constraint, we are limited to this. So that's about it. Moving on to the next slide, this is how the model works, or how we exactly curated the machine learning part of this model, or of this project exactly. So the crop data and the recommended NPK values were taken, and the data set was curated and was passed as the training data, which further went to model training. We did train a couple of models, of which the best chosen one was naive base, with the points keeping in mind of the lightweight mathematics behind it, and easier deployment scenarios, and easy explainability of the output. And once the model was exported, we have the user inputs, that's the NPK and pH values of the soil, which are to be given by the farmer itself. But the sensor data is via our sensor network, the grid system that we mentioned before. These both go into the model, which then makes the predictions or the recommendations based on the weather and the soil conditions. So that's about the machine learning module. And moving on.
So coming to the system architecture of our project, We have three sections here: machine learning, IoT, and Flask application. Machine learning part was just explained in the previous slide. So coming to the IoT module, the data is taken from the soil through the sensors. That data is transmitted from the sensor module to the receiver module. Then the receiver module transmits it to the cloud. Like as told in the previous slide, we are taking NPK and pH values from the user through the web page, and even those are stored in the cloud. Both of these are sent to the Flask application. Here we merge the data and we pass this to our model that was exported. That model returns the predictions, which will be displayed on the web interface itself. So that was about the architecture.
This is the architecture of the IoT module so that this system can transfer the data up to 1 kilometer. And we have followed many protocols here that we are using here is I2C, SPI, and UART protocols. And here we are using a various sensors like DHT11 for sensing the temperature and humidity, and FC28 soil moisture sensor used for sensing the moisture level in the soil, and MQ135 sensor basically used for detecting the gas around the surrounding of the field or the farmer land. And where these data will be read from the sensor and it will be converted into message packets. And these packets are transmitted to the receiver, while the receiver will decode that message packet and it will transmit it to cloud, and the cloud will be storing those data, and those data will be displayed to the farmer.
So, moving on to conclude what we did and the entire roadmap, after extensive literature survey, we found the pain points, we found what could be used in our model, then we brainstormed a little bit, and finally, after lots and lots of sleepless nights of coding, we achieved the objectives of this project. That is, we are now giving the crop recommendations and fertilizer recommendations to the farmer based on the soil contents or the soil conditions along with the weather conditions taken into consideration. Along with that, we are giving you real-time data of the soil to the farmer via our dashboard. That's the web page. And even Google Assistant integrations are done so that the farmer can easily access whatever is available in the network or the data or the recommendations directly at the palm of his hands. And we have done a MVP where the initial idea was to build a grid system, but due to budget constraint, that was limited. And now we have a sender, we have a receiver, which sends the data, which senses the data from the soil, sends it to the receiver, and the receiver further sends it to the cloud. And we take the data from the cloud and do some recommendations and give that to the farmer. So thank you all for staying us with this, and we're really happy to help farmers, and we hope this project uh, yields great results. Thank you, one and all.
Hello guys, this is how the LoRa transmitter node looks like. The current range of this transmitter is 1 kilometer at right now. The soil moisture sensor is put inside the soil and it will start giving the values. When we turn on the transmitter node, the LoRa will get initialized and we can see the sensor values on the LCD screen, and this thing will be transmitted to the receiver. At the receiver side, the receiver node will get the values from the transmitter and it will decode all the messages like the sensor values, and it will be transmitted to the cloud. And we can see the sensor values in the LCD screen that has been received from the transmitter.
Hello everyone. So this is the continuation of the presentation. So as you can see, our website has been hosted in the URL that is shown in the screen, rstify.freesite.vip, and this is the homepage of our website. The website is responsive and it is very user friendly, so it can be easily accessed by the farmers. So the homepage shows the different features of our website and all the other stuffs. It also has a login and sign up option. Our website is multilingual, so it can be accessed either in Kannada or in English. Okay. For the user to access our services, he needs to log in or sign up. Yeah, so the login and sign up has been taken care of by the Firebase authentication. So security is not an issue in our project. So if the user does not have an account, he is also has the option of signing up and creating an account. And once he is logged in, he will be directed to the dashboard.
So what you are seeing on the screen is the real-time data of the soil. Data is being sent from the sensors which are placed on the soil. These are the values we will be providing to the farmers. That is the values of methane, carbon monoxide, carbon dioxide, soil moisture, temperature, and humidity. And the values of the temperature and humidity is also used as some of the parameters to predict the crop. This was one of the objective of ours, that is to give the real-time data of what's happening inside the soil, and understanding what's happening inside the soil will definitely be a boon to the farmers. And this dashboard we built refreshes for every 1 minute. And if you scroll down, we have automatic irrigation system. If we turn off this automatic irrigation system, the user has to manually turn on or off the water pump. And if you turn on this automatic irrigation system, what happens in the background is our system first checks for the soil moisture level of that specified crop. If the soil moisture level is below the threshold, it automatically turns on the water pump. And if the soil moisture level crosses the threshold, then our system will automatically turn off the water pump. If you can see on the screen, the soil moisture level is 80, which is above the threshold value for that specified crop which we are predicting. So the water pump is not turned on yet. And when the soil moisture level goes below the threshold level of that specified crop, the water pump gets turned on automatically, and now you can see the water flowing through the pipe.
I can see that the NPK values and the pH value that were previously entered. So based on the values that I had entered previously, this is the recommendation for that. This recommendation is given on the basis of the NPK pH values, humidity, and temperature that you saw in the previous screen, along with the rainfall of the present location, is what is being taken into consideration to predict the crop. Now I also have an option of updating uh, my NPK values, because the NPK values keep changing around 6 months or so. And before we do that, let's just check what the fertilizer recommendation has to offer. So clicking this, here is how I need to take care of my crop. It says that the P value of my crop is high. So I just need to avoid adding manure and the other suggestions that are present here. Now, going back, let's just have an example of changing. Let's just give 71, 54, 24, and 6.5, and update table. So according to these, P's and P's is what's recommended. So you can see that our project is taking into consideration the real-time values of the soil, along with the entered inputs from the user, to make better recommendations to the farmer, along with the fertilizer recommendation. And now, concluding all this, let's just log out. And yeah, that's about it. Thank you.
Let's get the test version of Harvestify.
Hello, how can I help you?
What is the soil moisture level?
The moisture level of soil is 15.
Which crop should I plant now?
The suitable crop for your soil is pigeon peas.